Hello everyone, welcome to IGNOU Dost. So in this today's video, we'll talk about the problems in the section of Introduction to Matrices. So we will discuss the problems that we haven't discussed so far. We have discussed all the concepts in the previous video. So what are the problems that are there? That includes the concepts of the matrices we will solve in this particular video. All right. So let us start solving the problems. So this is the first problem. Determine whether the following matrix is a square matrix or row matrix or column matrix. That is the question. So you can see what is the matrix that has been given. That is 3, 4, 5. Okay. So we know that, as we can see, there are no columns here, right? There are no columns. Sorry, there are. Sorry, I mean to say there is only one row and multiple columns. Okay, so there is only one row and multiple columns, right? So if this is the case, when you have only one row and there are multiple columns, so this is the first column, second column, third column, and you have only one row, so then it is known as a row matrix. Okay, so a matrix that has only one row and 3 columns or 4 columns or multiple number of columns, then it is known as a row matrix, right? So that's the question number one. Question number two. If A equal to x235 and B equal to 1235 are equal, find the values of x. So this is the concept that includes, that is from the concept of, this is a problem that is from the concept of matrix equalities. So if two matrices are equal, okay, for that to happen, they must have rows to be the same, columns to be the same, corresponding elements to be also the same. Okay, so if you carefully observe here, A is a 2 by 2 matrix, B is a 2 by 2 matrix. So the number of rows in A is equal to number of rows in A. B, number of columns in A is equal to number of columns in B. And now, because that is done, we need to compare the corresponding elements. So if I compare corresponding elements, x will be equal to 1, 2 will be equal to 2, 3 will be equal to 3, 5 will be equal to 1. Okay, so from that we get x equal to 1 and 5 equal to 5. So this is how you approach this problem. Right? Coming to the next question. Find A plus B where A equal to 1, 2, 3, 4 and B equal to 5, 6, 7, 8. So very important to remember, we can add matrices. Okay, we can only add two matrices if their rows and columns are equal. Okay, that means the number of, if their number of rows and columns are equal, right? So if you are trying to add two matrices, both the matrices should have the same number of rows and same number of columns, and then you can add the corresponding elements. So if I add 1 to 5, it is 1 plus 5, that is actually 6. And if I add 2 to 6, 2 plus 6, that is actually 8. 3 and 7, 3 plus 7, that is actually equal to 10. And 4 plus 8, 4 plus 8, that is equal to 12. So you need to add the corresponding elements so that you get the final result. Coming to the next question. Calculate A minus B. So this is A that has been given to you. This is B that has been given to you. All right. So if you're trying to find A minus B, that means the same thing happens. Corresponding elements, you can take them and subtract, you get 5. 8 minus 3, that is equal to 5. 7 minus 2, that is actually equal to 5. 6 minus 1, that is actually equal to 5. Okay. So when you take two matrices, if you subtract them, you would get the required matrix. So again, the condition for matrices subtraction is also the same. The number of rows in both the matrices should be the same. The number of columns in both the matrices should be the same, right? So it's very, very important to remember all these points. Coming to the next question. Find 3A for the matrix A equal to 2, 0, 2 minus 1, 0, 4. So this is a very standard question of matrix multiplication. So you have a scalar, you have a matrix, and you just need to multiply. So whenever you're trying to multiply a scalar with a matrix, you just need to multiply the scalar with every element of the matrix. So 3 into 2, that is 6, right? 3 into minus 1, that is equal to minus 3. 3 into 0, that is actually equal to 0. 3 into 4, that is actually equal to 12. That's it. So the corresponding elements you will change by their sub result. Okay, so if you multiply their corresponding scalar with that particular element, you just replace that with the that particular result. Right? So this is how you do the scalar multiplication. Coming to the next question. So calculate AB. So AB in the sense the product of two matrices AB. So we have A matrix, we have B matrix, and they're asking us to find the product of these two matrices. So how do you find the product of two matrices? Again, the required condition for the product to happen is the number of rows, the number of columns, okay, the number of columns in A should be equal to number of rows in B. Okay, only if that is the case, you can actually multiply two matrices. Okay, if not, you'll not be able to multiply two matrices. Okay, so and also if that is the case, if in this case you can see the A is a 2 by 2 matrix, B is also a 2 by 2 matrix. So the number of rows in A is actually equal to number of columns in A is actually equal to number of rows in B. That is fine. Now, but how do you calculate AB? So AB in AB you will have this. Okay, so R1 C1 R2 C1 and R2 C1 and R1 C2 and R2 C2. Okay, so that means the first element, okay, the first element can be obtained by multiplying the row 1 with the column 1. So what is row 1? This is row 1. Okay, this is row 1. This is row 2. This is column 1. This is column 2. Okay, so the first element of the matrix can be obtained by multiplying R1 with C1. So if I assume AB, okay, 0 0 is basically, or you can say AB 1 1. So that means AB in the first row, first column element of AB is basically 1 2 multiplied by 0 2. Okay, so that is 1 into 0, 2 into 2, add them. Okay, so 1 into 0 plus 2 into 2, that is actually equal to 5. Okay, so this is the first row, first column element of the matrix A. Now coming to the second row, first column, so AB 2 1. Okay, so that will be R2 C1. So R2 C1 in the sense row 2, that is 3 4, and C1, that is 0 2. So if you multiply, you get 3 into 0 plus 4 into 2, that is actually equal to 8. Okay, that is done. Now calculating AB of 1 2. So AB of 1 2 in a sense R1 C2. So you can just take this corresponding numbers and put to the R and C. Okay, so row 1, what is row 1? 1 2. And what is C2? That is 1 3. Okay, so 1 into 1 plus 2 into 3. So that will give you the answer as 7. That is AB 1 2. Now AB 2 2 will be R2 C2. Okay, so row 2 and column 2. What is row 2? Row 2 is 3 4. And what is column 2? That is 1 3. So if you multiply them, you get 3 times 12. That is actually equal to 15. So that is the reason. This is AB 1 1. So this is actually 4, not 5. So 4, and we have 7 here. So 7. We have 8 here, that is 8, and we have 15 here, that is 15. So that is how you calculate the product of two matrices, right? So I hope you people have understood. Come to the next question. Find the transpose of the matrix A. So how do you find the transpose of any matrix? Interchange. So if they ask you to find the transpose, just interchange the rows with columns. Okay, so that is how you find the transpose of any matrix. Okay, so if you have this particular matrix that is 1 2 3 4 5 6, the A transpose will be, so this column 1, this is column 1, this is column 2, this is column 3. So this will be interchanged to row 1. Okay, this is row 1, this is row 2, and this is row 2. Okay, so your column 1 will become row 1, your column 2 will become row 2, your column 3 will become row 3. So this is in A, this is in A transpose, right? So that is what we have done. So your column 1 has been made as a row 1, right? Your column 2 has been made as row 2. Your column 3 has been made as row 2. That's it, right? So this is how we find the transpose of any matrix. Check if the matrix A is symmetric. Okay, so a matrix has been given to you, and you're asked to find if it is symmetric. So how do you see if how do you tell if a matrix is symmetric? So first condition is that A matrix, whatever it is, should be a square matrix. So square matrix in the sense the number of rows should be equal to number of columns. Very, very important condition. Second one, A transpose should be equal to A. Okay. So once you interchange the rows with columns and columns with rows, whatever the result that you get, that it must be the same matrix as before. Okay. So here if you see, this is column 1. Here if you see, this is column 2. That is in A. Now in A transpose, I need to write this column 1 as row 1. So that is 2 3. And this column 2 has row 2, that is 3 2. Okay, so this will be my row 1, this will be my row 2. So if you carefully observe, this is nothing but the same matrix here, right? So after doing the transpose operation, you are getting the same matrix as the final answer. So therefore, this is a symmetric matrix. So that is how we classify whether a particular matrix is symmetric or not. Coming to the next question. Is the matrix A skew symmetric? So how do you check whether a matrix A is skew symmetric or not? So again, the first condition is that must have the rows to be equal to the columns, same number of rows columns, that is a square matrix. And second one, A transpose should be equal to minus A. Okay. So unlike the condition of symmetric matrix where the A transpose is equal to A, in the case of skew symmetric matrix, A T should be equal to minus A, right? So if I take this thing, this is column 1, this is column 2, this is an A. Now in A transpose, I'll be having column 1 as row 1, so 0 minus 5, and column 2 as row 2, that is 5 0. So if you take minus 1 common, right, minus 1 outside, so I can take minus 1 into 0, 5, minus 5, 0. So this is basically nothing but minus 1 times A, right? This is basically nothing but A matrix, isn't it? So this is how you'll find the transpose of any matrix. Okay, so transpose operation is done. Once the final result is a minus of the original result, that means it is a skew symmetric matrix. If it's the same matrix that we have dealt with, then it is a symmetric matrix. Okay, so that is how we find whether a matrix is symmetric or not. Coming to the next question. Verify if the matrix A is orthogonal. So again, what is the condition for orthogonal? A times A transpose should be equal to an identity matrix, right? So the product of a matrix with its transpose should give you an identity matrix. So that is how when you say that a particular matrix is orthogonal. So in this case, this is a matrix that has been given to you. This is column 1, this is column 2. Now, how do you find A transpose? Column 1 will be a row 1, so this is 0 1, and column 2 will be a row 2, so this is 1 0, right? So this is row 1, this is row 2. Now the product multiplication, right? So the matrix multiplication. So for that, I'll just write A transpose here. So A transpose is basically 0 1 and 1 0, right? So this is the A transpose. Now how do you multiply? So this is row 1, this is column 1, right? And this is row 2, this is column 2. So in the A transpose multiplication, this will be R1 C1, this will be R1 C2, this will be R2 C1, this will be R2 C2, right? So that is R1 C2 in the sense 0 1 multiplied by 0 1. So that will give you 1. Okay, so that is 1. And this is R1 C1, right? And what about R1 C2? So R1 C2 is row 1 times C2, that is 0 1 times 1 1 0. So that is 0. Okay, so this will be 0. And R2 C1 is row 2 times C1, so that is 1 0 times 0 1. So this is 1 times 0 plus 0 times 1, that is again 0. So this will be 0. And R2 C2, that is actually what is row 2? 1 0. And what is C2? 1 0. Okay, so this will be 1. So this is okay. So A times A transpose is giving you 1 0 0 1. This is basically an identity matrix, isn't it? So the product of a matrix with its transpose is giving you an identity matrix. Therefore, the matrix A is an orthogonal matrix. So this is how you check whether a particular matrix is orthogonal or not. Coming to the next question. Solve for x if 2x is equal to 2x plus 1 2 3 4 equal to 5 6 7 8. So like you need to find the matrix X. Okay, you need to find the matrix X. So let us assume X is a matrix that is having A, B, C, D as its element. Okay, so 2 times X will be 2X will be 2A, 2B, 2C, 2D, right? And now you're adding this matrix with 1, 2, 3, 4. So if I add two matrices, the corresponding elements will be added. So this will be 2A plus 1, this will be 2B plus 2, this will be 2C plus 3, this will be 2D plus 3, right? And they're saying this is actually equal to 5, 6, 7, 8. 5, 6, 7, 8. So again, because they are equal, corresponding elements should be equal. So do the matching. So 2A plus 1 should be equal to 5. From this, I get A to be equal to 2. 2B plus 1, 2B plus 2 should be equal to 6, right? So this element, this should be equal to this. So from this, I get 2B is equal to 4. And again, I get B equal to 2. And from this 2 equal to equal. So 2C plus 3 should be equal to 7. And from this, again, I get C to be equal to 2. Again, if you compare these two, you get 2D plus 4 equal to 8. And from this as well, you get D to be 2. So you got A to be 2, B to be 2, C to be 2, D to be 2. Now that you got A, B, C, D values, so X matrix will be 2, 2, 2, 2, right? So that is the answer. I hope your people have understood. So this is how you'll find the matrix which satisfies the equation. Coming to the next question. Find the determinant of A. So we'll see what is determinant. Determinant is basically nothing but the multiplication, cross multiplication of the elements. So you have that of A to be equal to 1 times 4 minus 2 times 3, that is actually equal to minus. And this is the next question. So two matrices have been given. A is equal to 0 to 3 minus 4, and K times A is equal to 0, 3, A, 2B, 24. Okay. Then find the value of B minus A minus A. That is the question. Now, if you carefully observe, this is the A matrix and this is KA matrix. Okay. But if you actually see from this, this particular thing, if A is this 0, 2, 3, minus 4, then K times A, where K is a scalar or constant. So if you multiply K times A, this will be 0, this will be 2K, this will be 3K, this will be minus 4K, isn't it? That is K times A. But they have given K times A to be 0, 3A, 2B, 24, isn't it? So this is what they have given. That means if you can try to equate the corresponding elements, because this is also Ka, right? They both are Ka. So you can equate the corresponding elements. So 0 will be equal to 0, 2K will be equal to 3A. Okay, that is one equation. 2K will be equal to 3A. And 3K will be equal to 2B. 3K will be equal to 2B. And the other thing is minus 4K is equal to 24. So minus 4K equal to 24. From this, I get the value of K to be equal to minus 6. If I get K to be minus 6, then from this equation, okay, so 2 times minus 6 will be equal to 3 times A. So from this, I can get 3A equal to minus 6, right? So A equal to minus 4. And again, from this equation, 3 times minus 6 will be equal to 2 times B. So from this, I get B value to be equal to minus 9. Okay. Now that I've got A value, I have got B value, I have got K value. So I just add them up. So B minus A minus K is what they've asked. So minus 9, minus of minus 4, minus of minus 6. So that will be basically 1. Okay. So that is how we solve this question. I hope you people have understood. Come to the next question. So there have been so and matrices A of size 2 by 3 and B of size 3 by 2 be multiplied. So they're asking whether we can multiply two matrices where A is of size 2 by 3 and B is of size 3 by 2. Can we multiply them? So we know the condition for two matrices for multiplication. What is it? The number of columns in the first matrix should be equal to the number of rows in the second matrix. So if you carefully observe, the number of columns in A is equal to 3. The number of rows in B is equal to 3. So because 3 is equal to 3, we can multiply them. And also now if you multiply, okay, so A times B, that is 2 times 3 multiplied by 3 times 2. What happens is these two gets cancelled. You can just remember like this, and this will be left out. So this will be the new order, or then this will be the size of the product matrix. Okay, so that is how you find the AB. So this is fine. AB is fine. But what about BA? BA is multiplying by 3 by 2 multiplied by 2 by 3. Isn't it? Am I doing it correct? Yes. 3 by 2 is equal to 2 by 3. Okay. So B is of size 3 by 2 and A is of size 2 by 3. And okay. And we are trying to multiply both these uh, matrices. And we see that 2 and 2 gets like both of them are same. Okay. So the number of columns in B is actually equal to number of rows in B. So we can also try to multiply them so that we get a 3 by 3 matrix. Okay, we get a 3 by 3 matrix. Okay, come to the next question. So we have been given with the matrix A, that is 1, 2, 3, 4, and they're asking us to find the product of A transpose A. So how do you find A transpose? So your row 1 will become the column 1, your row 2 will become the column 2. Okay, now that we have got A transpose, now we can just multiply. So A transpose A is basically, so this is the multiplication. So how do you find it? So row 1 C1, row 2 C1, row 1 C2, row 2 C2, right? So this is how you do it, isn't it? So row 1 C1, R1 C1 will be equal to 1 3 times 1 3, so that is 10, and R1 R2 C1 will be equal to row 2, that is 2 4 times C1, that is 1 3, so that is 14, and R1 C2 will be equal to 1 3 times C2, that is 2 4, so that is actually equal to 2 plus 12, that is equal to 14 again, and R2 C2 will be equal to 2 4 times 2 4, so that is 4 plus 4, that is actually equal to 16 plus 4, that is equal to 20. Okay, so this is how you will find all the values, and then you can just substitute, and this is what you're going to get the final answer. A transpose time A is equal to 10 14 14 20. Come to the next question. So given A equal to 1 2 3 4 and B equal to 0 1 minus 1 0, find the matrix X such that X plus A equal to 2 times B transpose. Okay, so first thing, compute B transpose. So how do you compute B transpose? Your column 1 in B will transfer to be row 1. Your column 2 in B will be transferred as row 2, right? So that is how you get. And now you need to multiply 2 to every element so that you get 2B transpose as this. And now x plus a equal to 2B transpose. So x will be basically 2B transpose minus a. So 0 minus 2, 2 0 minus 1, 2, 3, 4. Okay. So because now that you have got 2B transpose, that is this, and A is this 1, 2, 3, 4, right? So corresponding elements you can just subtract. So 0 minus 1, that's minus 1, minus 2 minus 2, that's minus 4, 2 minus 3, that's minus 1, 0 minus 4, that is minus 1, right? So that is how we get the value of the matrix X. I hope you people have understood. So this ends up this section. We have discussed 16 problems nearly. We have discussed all the concepts related to introduction to matrices. So please make sure to go through these concepts and solve the problems.